geometric sequences is our next topic. It is a geometric sequence or series if the ratio between the terms is constant. What that means is if you are always multiplying or dividing by a common number, then it is a geometric sequence. So if we're looking at how to find a specific term or write a formula for a sequence, and this is an explicit formula, explicit geometric formula, it will be a sub n equals a sub 1 times r to the n minus 1. If you're looking at how to find the sum of the first n terms, we call it s sub n, s for sum, and it is a sub 1 times 1 minus r to the n all over 1 minus r. The last formula is how to find the sum of an infinite geometric sequence, and that is s sub infinity, because it's for an infinite number of terms, and it equals a sub 1 over 1 minus r. We will talk more in depth about these in class, so if you're missing class, I'm just going to run through kind of how each of these formulas work if you want a little more explanation. So this first one, if you're looking for how to find a certain term, with geometric series, you're always multiplying to get to the next term. So you see a sub 1 because that's your starting term, and then you're always multiplying by the common ratio because it's geometric. And this n sub 1 will be the number of times that you have to multiply to get to a certain term. The sums, this one is if you have a certain amount of terms you're trying to add up. This one is if you are looking for an infinite amount of numbers. This one is, it is what it is. It will add up a certain amount of terms. This one might be a little bit difficult to wrap your brain around because what you're doing is, let's say, for example, you're multiplying, or you're adding up 10 plus 5 plus 2.5, and it goes forever. It might seem difficult to understand how you can add up an infinite list, but as you can see, the numbers are getting smaller and smaller and smaller and smaller, and because they end up getting so small that they end up almost adding 0, you can say what they would add up to, if you went to forever, because those numbers that are way off at the end of the line really aren't adding hardly anything to your sum. So if you use this, for example, this one would be 10 over 1 minus, my common ratio here would be half, because you're always multiplying by half to get to the next one. It would be 10 divided by half, which is 10 times 2 over 1, which was 20. So this sequence would end up adding up to 20.